Thanks for joining us in this second episode of the Vantage series on LED dimming. Here at Vantage, we've been studying LED light sources for several years now and examining how they interact with dimmers. There have been some marvelous advances in LEDs over the years. The high efficacy of LEDs and the corresponding energy and cost savings, their long life, and the continual performance improvements and price reductions that we see indicate to us that LEDs will soon become the dominant technology in the lighting market. The purposes of dimming LEDs are really no different than that of other light sources, including appropriate ambience, multiple uses of the space, energy savings, and product lifespan extension. LED lighting manufacturers are therefore challenged with the task of making their products dim well. Today we will examine some of the issues related to dimming LEDs. Whether you're exploring dimmable LEDs for new construction or looking to replace incandescent lights with LEDs, the issues that we discussed today are relevant. We'll use the context of LED lamp replacement to simplify our discussion. In the lamp replacement context, we're just replacing an existing incandescent lamp with an LED lamp designed specifically for that purpose. This project is often undertaken by a homeowner, not considering that the replacement lamp may not dim as well as the original. If you are a Vantage homeowner considering relamping with LEDs, we strongly suggest you contact your dealer for consultation and assistance in evaluating your options and then optimizing the performance of the LEDs on your dimmers. In the market of LED replacement lamps, not all options are dimmable. Typically, a dimmable LED lamp will be marked as such. If no additional comments are made on compatible dimmers, you can safely assume that a lamp marked as dimmable is referring to compatibility with forward phase dimmers. This is because LED manufacturers know that most installed dimmers are of the forward phase variety. The most notable exception in replacement lamping will be a low voltage light fixture, such as those holding an MR16, which, depending on the transformer type, might be connected to a reverse phase dimmer. Now, the term dimmable is not something that has been standardized to date. What does it mean to be dimmable? Let's consider that there are two aspects to dimmability: compatibility and performance. An LED lamp that is compatible with a particular dimmer is one that is okay to place on that dimmer. Typically, little or no performance rating is suggested. Compatibility suggests only that it will dim to some level and that there will be no detriment or damage either to the dimmer or the LED lamp. Compatibility may be constrained by the number of lamps on a given dimmer output, with potential restrictions both on the minimum and the maximum numbers of lamps on that dimmer. Although LED lamp manufacturers typically provide little to no information that will help you with this. Now, going beyond compatibility, our interest is in the performance of the lamp controlled by a given dimmer. Performance issues include dimming range, flicker, smoothness, and linearity. Because there are no performance standards, and because of the different characteristics of dimmer models, and because of the wide performance variation from one LED light source to the next, the only way to assess performance and optimize performance against a particular dimmer is to test samples of the light against that dimmer. Vantage conducts testing on LED light sources. Within the Resources and Tools section of the Vantage Professional Support website, dealers and specifiers can find LED product test results for several commercially available LED lights. To correctly interpret these test reports, it is vital to understand the performance issues reported. Please keep in mind that Vantage is not in the business of recommending one lamp or fixture over another, but will provide dimming test results for your consideration to help you in your decision making, as you consider as well the requirements of the application, pricing, and non-dimming performance issues such as color temperature, lumens output, beam spread, etc. The first LED performance issue we'll examine is dimming range limitations. While it is inherent in the incandescent lamp to be able to respond at even the lowest dimming settings, providing very low lighting levels throughout the bottom of the dimming range, the same is not typically true of LEDs. Rather, these will have a limit as to how low they can be dimmed. Attempts to dim beyond that limit will often lead to unacceptable behavior, such as flicker, pop-on, or drop-out. This is a limitation of the LED driver built into replacement lamps. The function of the LED driver is to supply and regulate the current supplied to the LED. The light output of the LED is directly proportional to the current flowing through it. Current regulation becomes more difficult at the low end of the dimming range, thus the limit. The low end limit varies greatly among LED lighting products depending on the driver's current regulation capabilities. We will here demonstrate the range limit characteristics of LEDs. We have placed two light sources, one incandescent, the other LED, side by side together on the output of a forward phase dimmer. We start with the dimmer turned off and we will turn the dimmer on to just 1%. As you can see, the incandescent light is already beginning to glow. So we can bring the incandescent light level down as far as we may wish. As I increase the dimming set point to 2, 3, and 4%, you can see the incandescent lights grow, but we still don't have any light out from the LED. As we continue to increase the set point, we finally reach a point where the LED light will shine. Notice how bright the LED is in comparison to the incandescent. This is the limitation we're speaking about. If we desire to achieve lower light levels than what you see here with this light, we will be disappointed. This is a limitation we must live with if we select this LED lamp. What you have just seen is a phenomenon known as dropout. If we made no adjustment to the dimmer with this LED lamp, it would be possible to have the lamp turn off while the dimmer is on. To make sure the light is always on when the dimmer is on, we would adjust the low-end trim of the dimmer high enough that we eliminate the portion of the range where the LED does not perform. But before we do that, let's examine what happens when we drop the dimming level while the light is shining. Notice that I can decrease a few percent and the light remains lit, even getting dimmer. So it might appear that we had set a false floor. However, we have just demonstrated the phenomenon of pop-on. Here, we dim a light that is on down to the minimum level. Then when we turn the dimmer off, then back on to this low level, it won't turn on. Its behavior depends on the previous state of the light. If we set our low-end trim this low, we will have to deal with this pop-on effect, which we typically like to avoid. To set the low-end trim of a Vantage dimmer, we adjust the minimum on level of the lighting load's corresponding power profile. Once the minimum on level has been established for a specimen, the floor of the dimming range is fixed and it will not go any lower. If your lighting application requires very low lighting levels, you will want to take this into consideration when selecting replacement lamps. Some examples of applications where low levels are desirable are media rooms, dining areas, and bedrooms. The good news is, as LED driver current regulation improves, we are seeing samples that are very impressive in their ability to perform at progressively lower levels. While on the topic of low dimming level applications, the color characteristics of the light output should be considered. Because of the way the incandescent filament behaves, the color of the light grows more amber as it's dimmed. By contrast, the color of LED lamps typically stays pretty much the same as when full bright. We often find the difference objectionable, expecting a warm candlelight experience, but getting instead a cold moonlight feeling. There are LED manufacturers who are experimenting with new technologies applied to their LEDs to produce this warming effect at the low end of the range, but these offerings are still on the horizon. The next performance consideration is flicker, which is demonstrated here. Again, there is no standard, and it is not common to measure flicker during dimming tests, but simply to state the tester's subjective observance of flicker. It is important to realize that all lights have some flicker, but the level of flicker should be below the threshold of detection of the users of the space. If they can detect it, users may find flicker unacceptable. Furthermore, children, migraine sufferers, and autistic persons, as well as photosensitive epileptics, will suffer as a result of flicker that may not affect others. If any of the users of the space are within this group, low flicker is a very important consideration. Smoothness is yet another performance consideration. This refers to the way the light changes as the dimming level is changed. Our experience with incandescent lights, assuming a quality dimmer, tells us that as we change the dimming level, the light reacts smoothly without noticeable level steps or jumps. Whenever a dimmer is set to change levels with a transition, this can be an important consideration. Whether a long transition, such as in a home theater when the watch movie button initiates a long fade down to the low lighting levels appropriate for the activity, or even the 1 to 3 second transitions we enjoy in a typical Vantage home, when lights turn on and off, may be long enough to make stepping during transitions unacceptable. Some LED lamps are very smooth, others not so smooth, and the stepping can even appear as flicker to the casual observer, depending on step size and transition rates. However, we can see that it does not flicker because it remains steady at any given dimming level. The final performance issue is linearity. Please watch for our third episode of this series in which we will deal exclusively with the issue of dimming linearity. Thanks for joining us today. In summary, we have examined some of the dimming performance issues of LED lighting sources that typically don't arise with incandescent lamps. It is important to remember that just because a manufacturer claims their LED light source is dimmable doesn't mean that its performance will meet the expectations of the users of the space. While we can eliminate unacceptable behaviors by setting an appropriate low-end trim to the dimmer, we cannot improve upon other performance-related issues such as mid-range flicker, non-smooth transitions, and minimum light output levels and color. So, these performance issues must be examined and evaluated against the requirements and expectations for the application. Vantage continues to test and is willing to test LED samples at the request of LED manufacturers, our partners, and customers. Please contact Vantage Technical Services for sample testing requests or for questions you may have relevant to the topic.